And good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So eventually today, we are going to take a look at section 14.3. Your homework tonight is to complete section 14.3 as well as the test review material. Monday, we'll have a review, and then Tuesday, you'll take your first test. All right, so now let's see here. Just want to remind you, I have an office hour that's from 1:15 to 2:15 p.m. daily. You can come and join that. There's a math center that has a Zoom ID here. You can join that at any of these times to get help. A couple of things about people have been sending me emails requesting me to do problems, and that's great. I appreciate that. Some other things I would appreciate as well. Be sure that your name is on it, because some of you, for whatever reason, the name that appears, like whoever's email you're using, is not you. And so then I have to go back and figure out who that is. Okay, so it'd be great if you said, hey, Mr. Mayo, this is so-and-so. Another thing is if you could tell me the actual section that you want help with, because I had an email from a student that it just said, yeah, can you do this problem? And there was no problem there. So then I texted your email and say, hey, what problem? They told me, but it's like, anyway, if you could give me your name, rank, and serial number. No, your name and which section of the book, and then which problems, that would be great. Also, if you could get those to me before 10 a.m., that's great. You can also bring them to class like some of you are doing now. That's fine. But I'm just saying, I do all my prep for what I'm going to do before 10. Okay, having said all of that, let's take a look at this problem. This is from section 14.2. It says, find 3 arithmetic means between 10 and 24. All right. Because we're looking for arithmetic means, we're going to use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d, where n is the number of the subscript of the term and d is the common difference. All right. We know that the first term is 10. We know that after 10, we are to have 3 arithmetic means, which means the last term would be a sub 5, which is also 24. Any questions about how I knew that 24 was a sub 5 as opposed to a sub something else? We okay with that? All right.
Wait,
so yes.
You get all the way to like 5?
Okay, so we were given the first term, which was 10, which is right here. Okay. Then we were told there were 3 arithmetic means between 10 and 24. So here's 1, 2, 3 arithmetic means. And then the final term was 24. So we've got the first term and the last term and 3 terms in the middle for a total of 5. Does that make sense?
Yeah.
Okay, good, good. You betcha. Let's tidy things up there. Okay. Now, I know because I'm told that a sub 5 is 24. But I also know using the formula that a sub 5 is a sub 1, which is 10, plus n minus 1, where n is 5, so n minus 1 times d. I don't know the common difference yet. Any questions about how I did that? Okay, I can tidy this up a little bit more and say a sub 5 is 24 and a sub 5 is 10 plus 5 minus 1 is 4, so 4d. Because a sub 5 equals 24 and a sub 5 equals 10 plus 4d, I can put those two together to create an equation 24 equals 10 plus 4D. This will now allow me to solve for D. I'll subtract 10 from both sides of the equation. 14 equals 4D. I'll divide both sides of the equation by 4. D equals 14 over 4, which could be reduced to 7/2. So D equals 7/2. So now A sub 1, oops, I didn't label this. A sub 1 plus 7/2 is A sub 2. A sub 2 plus 7/2 is A sub 3, etc. Well, to get A sub 2, I need what? 10 plus 7/2. To combine a whole number with a fraction, we need a common denominator. 10 is the same thing as 10 over 1. The common denominator would be 2. So I'm going to multiply 10 over 1 by 2 over 2. This will get me 20 over 2 plus 7 over 2, which is 27 over 2. So A sub 2 is 27 over 2. Any questions there? All right. To get A sub 3, I take A sub 2, which is 27 over 2, plus D, which is 7 over 2, which is 34 over 2, which simplifies down to 17. 17 plus 7 over 2 is A sub 4. Well, 17 is the same thing as 34 over 2. So 34 over 2 plus 7 over 2 is 41 over 2. Okay, let's check to see. 41 over 2 plus 7 over 2 should be 24. Let's see, 41 over 2 plus 7 over 2 is 48 over 2, which is 24. So there's your correct answer. Now, I believe what WebAssign does is down at the bottom where you put in the answers, it'll have the first term given and the last term given, and then you fill in the 3 arithmetic means that it asked for. All right. So any questions about this particular problem before we move on?
I put in decimals instead of fractions and I still got it right. Is that okay?
It's okay because 27/2 is exactly 13.5. 41/2 is exactly 20.1. So yes, where you get into trouble though, is let's say you have 2/3 and you punch it into your calculator and it says 0.6666666, etc. So technically it's 0.6 repeating. And then you round it off and you write 0.6 and it's wrong. So you don't want to round off a repeating decimal. If
So
it's
you put in the fraction.
Yeah, an exact decimal is fine unless it asks for a fraction. But so the safe way is to use fractions, but if it's an exact decimal, absolutely. In fact, you know, one could argue that in this case, where D is 7/2, which is 3.5, it would be much easier to take 10 plus 3.5 and get 13.5, plus 13.5 to get 17, plus 3, you know what I'm saying? And that's great, as long as it's an exact decimal, okay? All right, good, good, good. Let's see. Next up, we've got some more questions. This is from 14.2 as well. And this is problem number 6. And it says, write the first 5 terms of the sequence. So we want the first 5 terms of the sequence. And the sequence is A sub n equals -4n plus 1. Now, recall from yesterday, if it gives you a specific sequence formula to use, that's what you use. If it doesn't give one and it just says the arithmetic sequence, that's when we use that A sub n equals A sub 1 plus the quantity n minus 1 times d. So in this case, we're using this given formula. They want the first 5 terms. So how are we going to find them? We're going to plug them into the formula. So A sub 1 is -4 times 1, because 1 goes in the place of n, plus 1, which is -4 plus 1, which is -3. Any questions how I did that? All right. A sub 2 is negative 4 times 2 plus 1, which is negative 8 plus 1, which is negative 7. A sub 3 is negative 4 times 3 plus 1, which is negative 12 plus 1, which is negative 11. A sub 4 is negative 4 times 4 plus 1, which is negative 16 plus 1, which is negative 15. And finally, a sub 5 is negative 4 times 5 plus 1, which is negative 20 plus 1, which is negative 19. So there are the first 5 terms of that arithmetic sequence. Okay, or that sequence. We okay with that? Yeah. In fact, the directions on this one say, find the first 5 terms of the sequence. So it doesn't specify that it's an arithmetic sequence, which is fine. And maybe I shouldn't have made that or shouldn't have called it that. All right, we're going on. 14.2, this is number 7. Write the first 4 terms of the sequence. So first 4 terms of this particular sequence. And it looks like this. A sub n equals negative 1, the quantity to the n power, over 3 to the n power. I want to point out, it isn't 1 to the n power with a negative sign out front, it's negative 1 to the n power. So the negative is part of the base. And we need the first 4 terms. So a sub 1, a sub 2, a sub 3, a sub 4. So using the formula, a sub 1 is negative 1 to the 1 power over 3 to the 1 power. Negative 1 to the 1 power is negative 1. 3 to the 1 power is 3. So a sub 1 is negative 1/3. A sub 2 is negative 1, the quantity squared, over 3 squared. Negative 1 times negative 1 is positive 1. 3 times 3 is 9. A sub 3, negative 1, the quantity, cubed, over 3 cubed. Negative 1 times negative 1 times negative 1 is negative 1. 3 cubed is 27. And finally, here, let's see if we can put a sub 4 is negative 1 to the 4th power over 3 to the 4th power. Negative 1 times negative 1 times negative 1 times negative 1. You have an even number of negative factors, so it's going to be a positive number. So 1 over 81. So there's the first 4 terms of that sequence. Any questions about that one? Okay, we're still in 14.2, and this is number 13. It says, write the first 5 terms of the arithmetic sequence with the following properties. And it doesn't give us a sequence, so we're going to use a sub n equals a sub 1 plus the quantity n minus 1 times d. As I mentioned yesterday, you can have this formula on a note card as well as a formula we're going to look at today. That's all you can take with you for the test, but you can have those 2 formulas. All right, you can take your brain with you. No, that's a good idea. Let's see here. What does it say? Write the first 5 terms of the arithmetic sequence with the following properties. Okay, so I need 5 terms. It says the first term is negative 3 and the 6th term, is negative 38. So they give us the first term and the 6th term. They want to know the first 5 terms. Well, I already have the first one, it's negative 3. So what I'm going to do, I'm going to take the fact that a sub 6 equals negative 38, because that's given. Using the formula, a sub 6 equals a sub 1, which is negative 3, plus n minus 1. In this case, n is 6. So 6 minus 1 times d, the common difference. Tidying up that right-hand formula, a sub 6 is -3 plus 5d. So a sub 6 equals -38. A sub 6 equals -3 plus 5d. So we get an equation, -38 equals -3 plus 5d. Again, any questions there so far? So now I will add 3 to both sides of the equation. -35 equals 5d. I'll divide both sides of the equation by 5. D equals -7. So a sub 1 plus d is a sub 2, a sub 2 plus d is a sub 3, etc., etc. -3 plus -7 is -10. -10 plus -7 is -17. -17 plus -7 is -24. -24 plus -7 is -31. And just to check that we come out right, -31 plus -7 is -38. So there are the first 5 terms of that sequence. Any questions about that? All right, give me a minute here to find another problem that was requested. And let's see here if I can find the students account. Okay. 14.2, number 7. Okay, so this is 14.2, number 7. It says, write the first 4 terms of the sequence. And the formula is a sub n equals -1 to the n power over 2 to the n. We did one similar to this a little while ago where the denominator was 3 to the n. So we want the first 4 terms, a sub 1, a sub 2, a sub 3, and a sub 4. So a sub 1 is going to be -1, the quantity to the 1 power over 2 to the 1 power, which is -1 over 2. Okay. A sub 2 is -1, the quantity to the 2 power over 2 to the 2 power, which is 1 over 4, the 2 power. A sub 3 is -1 to the 3rd power over 2 to the 3rd power. -1 times -1 times -1 is -1 over 8, so -1/8. And a sub 4 is -1 to the 4th power over 2 to the 4th. -1 times -1 times -1 times -1 is +1 over 16. So there's that one you were asking about, Yola. All right. Anything else before we go on to section 14.3? Okay, and that's what we will do. So give me just a second here. That and here. So 14.3. Put on my glasses so I can see. Okay, so yesterday we looked at arithmetic sequences where you had a formula like this. A sub 1 was the first term, n was the subscript of the particular term we were looking for, and d was the common difference. To find the common difference, we took any term in the sequence minus the previous term. So like the 3rd term minus the 2nd term, or the 2nd term minus the 1st term, to give us the common difference. Okay, so that's sort of a quick review. All right, now 14.3 is geometric sequences. Okay, and geometric sequences have the following formula: a sub n equals a sub 1 times r to the n minus 1 power, where R is called the common ratio. And here we're taking a term and multiplying it by the common ratio to get the next term. We're taking that term and multiplying it by the common ratio to get the next term, et cetera, okay? Now, in an arithmetic sequence, you take a term minus the previous term to get the common difference. In a geometric sequence, you find the common ratio by taking a term divided by the previous term. So if we took a sub, oops, not a sub n, a sub 2 divided by a sub 1, that would give us R, that common ratio. And again, we're going to put all that into practice here. If I could find the page with the homework on it. Here we go. Okay. Write the first 5 terms of a geometric sequence with the given properties, and then find the specified term. Okay, so it's a geometric sequence. So we're going to use a sub n equals a sub 1 times r to the n minus 1 power. Okay, we want the first 5 terms. So we want a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, and then find the specified term as well. We are told that the first term is 3, the common ratio is 2, and they also want us to find the 9th term. So we want the first 5 terms and the 9th term. Okay. All right. Now, since we know the common ratio, we could say a sub 1 times the common ratio is a sub 2. A sub 2 times the common ratio is a sub 3, etc. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. Now I could continue and go a sub 6 is 96 and a sub 7, etc., etc. But I could also just plug in the information I'm given because I know everything I need. A sub 9 is a sub 1, which is 3, times r, which is 2, to the n minus 1 power, which would be to the 9 minus 1 power. So that's 3 times 2 to the 8th power, which is 3 times, let's see, what is 2 to the 8th power? 2 to the 8th power is 256. So that times 3 is 768. Okay. So there's the first 5 terms of that geometric sequence, as well as the 9th term. Any questions about this example? Okay, let's see here. This says, find the specified term of the geometric sequence with the following properties. The first 3 terms are 2, 6, 18. Find the 7th term. Okay, so we're looking for a geometric sequence. So a sub n equals a sub 1 plus n minus 1 times d. And we've got a sub 1 is given as 2, a sub 2 is 6, a sub 3 is 18. And we are to find a sub 7. So again, we're looking for a oh, what did I do wrong? Can somebody tell me?
Put the wrong formula
I
up.
put the wrong formula. Sure did. Okay, I was distracted by somebody's cute little girl that was giving me peace signs. She's gone now. All right, r to the n minus 1 power. Sorry about that. Okay, so we want to find the specified term of a geometric sequence with the following properties. The first 3 terms are 2, 6, and 18. Find a sub 7. Okay, we need to find R, the common ratio. And as I said before, to find R, you take any term in the sequence divided by its previous term. So let's see, a sub 3 divided by a sub 2 is 18 over 6, which is 3. Now let's check another one. A sub 2 divided by a sub 1 is 6 divided by 2, which is 3. So I'm pretty convinced that the common ratio is 3. All right. So a sub 7 equals a sub 1 times the common ratio to the n minus 1 power, which is 2 times 3 to the 6th power, which is 2 times, let's see here, 3 raised to the 6th power is 729. And that times 2 is 1458, 1,458. As we're doing these, if anybody has any questions like, how do you put 3 to the 6th power into a calculator or whatever, please ask and I'll go over that. But if you don't ask, I'll assume that you know how. So again, you would need to ask me or tell me if you have questions concerning that. Any questions at this point? All right. So let's see here. What's that?
How did you get the 2, 6, 18?
Those were given.
Oh, okay.
Yeah, it said, find the specified term of the geometric sequence with the following properties. And then it said, the first 3 terms are 2, 6, 18, and then find the 7th term. Okay, so yeah, they gave us those. All righty. I'll take that as a yes. Okay. Let's do one that's not so nice. Find the specified term of the geometric sequence with the following properties. Okay, so this is basically the same kind of problem. It tells us that the first 3 terms are 1/2, -5/2, and 25/2. Find the 6th term. So again, they've given us the first 3 terms of a geometric sequence. Let's see if I can get the formula right this time. So a sub n equals a sub 1 times r to the n minus 1 power. Okay. So I need to find r. If I take any term in the sequence divided by the previous term, I get r. How about if we take a sub 3 divided by a sub 2? So 25/2 divided by -5/2. That's the same thing as 25/2 divided by -5/2, right? But recall, dividing by a fraction is like multiplying by its reciprocal. So this becomes 25/2 times 2 over -5, or -2/5. We can put that negative sign in the numerator or the denominator. If it's a final answer, we'll leave it in the numerator, but right now it's not the final answer. So let's see. I could reduce this down. The 2's reduced down to 1/1. The 25 over -5 reduces to -5/1. So basically R is -5. Any questions about how I found R? I could have taken a sub 2 divided by a sub 1 and I should have gotten the same thing. Okay. All right. So now using this formula, a sub 6 equals a sub 1, which is 1/2, times r, which is -5, to the n minus 1 power, or 6 minus 1 power. So that becomes 1/2 times -5 to the 5th power. Now, if I take the quantity -5, so parentheses, -5, close the parentheses, raised to the 5th power, I get 1/2 times -31/25. Okay. If I take 1/2 times -31/25, I get -31/25/2. Now, here's a case of where The improper fraction is correct. You could write it as a decimal because it comes out exact, but I wouldn't go to the trouble. I would just leave it as the fraction. Any questions about that one? Anything there? Okay, going on. Write the first 5 terms of the geometric sequence with the following properties. All right, they tell us that the first term is 2. Okay. The third term is 18. Now, again, it said write the first 5 terms of the geometric sequence. The first term is 2, the third term is 18. So I've got a sub n equals a sub 1 times r to the n minus 1 power. They also tell us the following. They say that r is greater than 0. So they aren't telling us what r is, other than that it is a positive number. And you might think, well, of course it is, or whatever, but let's take a look at how we're going to solve for this. Okay, now I need to figure out about what r is. I know that a sub 3 is 18. That's a given. I also know, using the formula, that a sub 3 is a sub 1 times r to the n minus 1 power. So a sub 3 is 2 times what, r squared, because 3 minus 1 is 2. All right, we okay so far? Now, a sub 3 equals 18, a sub 3 equals 2r squared. So my equation becomes 18 equals 2r squared. I need to solve for r. So the next step is going to be to divide both sides by 2. Okay, so r squared is 9. Now, later on in this quarter, we're going to go into a chapter where the whole chapter deals with roots, square roots, cube roots, radicals, all kinds of things. But for now, we're going to get just a little taste of it, just enough as needed kind of thing. Can you tell me what times what equals 9? Anybody? A number times itself that's 9?
3 times 3.
Right. 3 times 3 is 9. Is there any negative number that times itself is 9?
-3 times -3.
Yeah, -3 times -3. Now, formally, this is how we would solve this thing. We'd say r squared equals 9. We'll take the square root of both sides, but when we do that, we get r equals plus or minus the square root of 9, which is 3. So what I'm getting is 2 possibilities. R is a positive 3, R is a negative 3, the ones that we discussed up here. So there are 2 possibilities because 3 squared is 9, -3, the quantity squared is 9. But we want r that's greater than 0. So in this case, we're getting rid of the negative, and we're only going to use r is positive 3. Okay? This piece of information tells us to throw out the negative r value. Well, since r is 3, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and 54 times 3 is 162. There you go. Any question about what happened here or any other part of it? Okay. Let's take a look at another one. Let's see here. Doing for time, yeah. This says find the geometric means. Oh, remember how we did arithmetic means? We had like a beginning and an ending term, and then we found some means in the middle, some arithmetic means. Now we're going to find geometric means. It says find the geometric means to be inserted in each geometric sequence. Insert 3 positive geometric means between 2 and 162. So my first term is 2. then I've got 3 geometric means, and then my last term is 162. So how do I know that? I've got a first term given and a last term given, and they said there were 3 geometric means in the middle. I'm going to use the formula a sub n equals a sub 1 times r to the n minus 1 power. Okay. So here's what I know. I know that a sub 5 is 162. That's a given. Using the formula, I know that a sub 5 is a sub 1, which is 2 times r, which we don't know yet, to the n minus 1 power, which would be the 5 minus 1 power. Simplifying further, I get a sub 5 equals 162, and it equals 2 times r to the 4th power, 5 minus 1. So now 162 equals 2r to the 4th power. So there's my equation. 162 equals 2r to the 4th power. Any questions so far? So I'm going to divide both sides by 2, and 81 equals r to the 4th power. Okay. Let's see here. Hold on a second. Let's see where I got this one. 62. I lost track of, oh, there it is. There it is. Okay. Something I didn't emphasize. It said insert 3 positive geometric means. So instead of it having something like this, r greater than 0, it just said that these numbers here were going to be positive. Okay, that's what they told us. So we'll come back to that in a minute. All right, 81 equals r to the 4th power. So a number times itself, times itself, times itself is 81. Well, 1 times 1 is 1 times 1 is 1 times 1 is 1. So 1 to the 4th power is 1. How about 2 to the 4th power? 2 times 2 is 4, times 2 is 8, times 2 is 16. Well, it's not that. How about 3 to the 4th power? 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 times 3 times 3 times 3 is 81. Okay. Now, the following is true. -3 times -3 times -3 times -3 is also 81. But remember, they told us that they were positive means. Okay. If so, r is going to be 3. If I used r as -3, this is going to be -6. And this is going to be 18, and this is going to be -54, and I'm not going to get 3 positive means. So, in fact, let's erase that. That tells me r has to be a positive number. Okay, so 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, 54 times 3 is 162. So we have now inserted 3 positive geometric means between 2 and 162.
Mr. Mayo,
Yes.
how did you get the 1 squared 4 and then the 2 squared 4?
Okay, that was sort of a trial and error process. And what I was doing was I was saying, okay, I've got this situation here where r to the 4th power equals 81. So that means r times r times r times r equals 81, okay? You follow that?
Yeah.
Okay, so I'm trying to figure out, well, what is r? So I just sort of trial and error. I said, well, 1 times 1 times 1 times 1, that's 1. So 1 to the 4th power is 1. So r is not equal to 1. Okay, what about 2? What's 2 to the 4th power? That's 2 times 2 times 2 times 2, which is 16. So r is not equal to 2. What about 3? 3 to the 4th power, 3 times 3 times 3 times 3, and that turns out to be 81. So r to the 4th is 81. So that means r equals 3. So these were just me trial and error figuring it out. Now, later on when we get to chapter 9, we'll learn all kinds of fancy things. We'll use our calculator and everything to shortcut things. But for right now, I don't want to open a big can of worms, just give you enough to do these kinds of problems. So I'm just kind of using trial and error on them. We're not going to get some really huge number. What's the 18th root of 3,412,000? We won't be doing that, not even later. Okay. So you okay with that?
Yeah.
All
Thank
right.
you.
You betcha. Okay. So now, let's see here. This says, find a geometric mean to be inserted in each geometric sequence. Find the geometric mean between 2 and 128. So what we've got is we're just looking for one geometric mean, okay? So we're going to use the formula a sub n equals a sub 1 times r to the n minus 1 power. This is all they tell us. They don't tell us whether the common ratio is positive or negative. They don't tell us whether the mean is positive or negative. It just says, find the geometric mean between 2 and 128. Okay. Now, a sub 3 is 128. That's given, right? And a sub 3 equals a, oops, messed up here again. A sub 1, which is 2, times r to the 3 minus 1 power. So a sub 3 is 128. A sub 3 is 2r squared, 3 minus 1. So far, so good. Okay. So that means 128 equals 2r squared. So 128 equals 2r squared. We're going to divide both sides by 2. 64 equals r squared, or r squared equals 64. What times what equals 64? What's a number times itself at 64?
8.
Okay. Can you think of another number, a negative number times itself?
-8 times -8.
Right. So r could be 8 or r could be -8. Now, there's nothing in the directions to imply whether the r should be positive or negative. So we actually have two answers. One of them, let's say we use r as a positive 8. Then the second term would be 8. No, it wouldn't. The second term would be 16. Sorry about that. 2 times 8 would be 16. 16 times 8 is 128. Okay, so that one checks. What if r is -8? 2 times -8 would be -16, and -16 times -8, whoops, -16 times -8 would still be positive 128. So in this case, there are two answers. There is a positive mean, 16, and a negative mean, -16. Now, if you want to be an English major, as opposed to a French colonel, and you want to be really, really picky, you could say, well, but the directions said, find the geometric mean between 2 and 128. Well, doesn't that imply one of them? Well, sometimes math and English, things get a little fuzzy. So there are actually two answers. So maybe they should have said, find the geometric mean, and then in parentheses an S to imply there might be more than one. Anyway, so here are the two geometric means. All right, let's see here.
Mr. Mayo,
Yes.
how did you get how did you get -16 and -8?
So how did I get this? And
No,
this?
like down?
Here?
Yeah.
Okay, okay. So if I use r equals 8, a sub 2, this is 2 times 8, which is 16. If I use -8, then a sub 2 is 2 times negative 16, which is, oh, excuse me, 2 times negative 8, which is negative 16. Okay, which gives me that. Now, just to confirm that, yes, that works, if I take that times negative 8, in other words, a sub 2 being this number, times negative 8, I get positive 128. In other words, if a sub 2 is positive, positive times positive equals positive. If r is negative, positive times negative is negative. Negative times negative takes us back to positive. So with two positive terms there, the middle term, the mean, can be positive or negative and still work out. Did you follow that?
Yeah.
Okay, but this came from taking a sub 2 is negative 16 and the negative 16 times negative 8. Yeah, it gives us 128.
So it doesn't
Mr.
matter.
Ferriero. Oh, sorry, go ahead.
So it doesn't matter if it's negative or positive as long as it equals 128.
As long as by the time we get here, it's back to 128, right?
Oh,
Right.
yeah.
Yeah, and again, how do you know that it could be either of these? There was nothing in the directions to imply r is positive or r is negative. And when we plug them both in, we still get the same a sub 3 value. Okay, now, we looked at a couple of them where they said r was positive. There might be a case where it says r is negative, and then you would only consider the negative value. So the bottom line here is read all of the directions, all the little details. I had a student several years ago who was taking a reading class at the same time they were in my math class. And the instructor of the reading class was teaching them how to skim read, sort of to read faster by skimming what you're reading rather than literally reading each word. And that might work great for speed reading, but in math, you do not want to skim read. You want to read each and every little detail because the smallest detail can change everything. So in fact, quite often, I'll have a student asking me a question, they keep getting the wrong answer, and what it turns out to be, they weren't reading the directions. I myself have been guilty of that as well. So you got to be really careful, don't get in a hurry, etc., etc. Okay, so yes.
When we put it in for the answers in the answer box, and it is like 16 and negative 16, do we put a comma between the two?
The directions in WebAssign should tell you. They'll usually say separate, separated by a comma. Okay. So yeah, so like for this one, you'd have, it might say r equals, you go negative 8, comma 8 kind of thing. Okay. But again, the directions should tell you that. And be careful, because if it says separated by a comma and you put that in there, it's going to think you've got negative 88 and it's going to be wrong. And you're going to be going, what's wrong with it? I've got the right numbers. So I cannot overemphasize, though I will try to overemphasize reading the directions carefully. Okay. All right. So over the weekend, you're going to wrap up this chapter. You've got homework in section 14.3, as well as test review questions. So that's 2 sections of homework. I will see you. I'll be back this afternoon at 1:15 to 2:15 if you have questions, or I will be back Monday morning at 10:30. So have a great weekend and be careful out there. I'm going to go ahead and stop the recording. Right.